This is section 2.4, the last section of chapter 2, and this has to do with solutions of linear inequalities. So we're still in the linear theme in this chapter. But again, all the skills that you learn from this chapter and last chapter is building, and then eventually you'll just morph those skills into different types of equations when we get into logs and quadratics, cubics, even to the 6th power. It won't matter. It'll just be a little bit more complex of what we've already been doing. So solving an inequality means finding its solution set, and you should be able to write a solution set now after the last chapter as an inequality, as interval notation, and graphing on a real number line. We practiced that on our first test. 2 inequalities are equivalent if they have the same solution set. And solution sets for inequalities are not a point. It is several points. So for instance, if I had an inequality like these were my lines, but on this one I shaded this way. If you remember this from Algebra 2, and this one I shaded this way, the actual solution that is true for both of these would be in this set right here. So we would definitely want to be able to find this point here and these boundaries here. This one's a solid one. This one would be a dotted one. And we're going to be doing these in word problems. So here's the first one. For an electronic reading device, the respective weekly revenue and weekly costs are given by these equations right here. So revenue and cost. So this is the money they would take in at the rate they would take it in, and this is the cost at the rate of their costs that they have. Think about the $16,000, that would be like a fixed cost. So if I had to rent a warehouse building and pay my employees and pay all the utilities, even if I sold nothing, I would still have that cost. So this would be more like a fixed cost. And then depending on the number of units sold, this would be a cost associated with that per unit. And this X is the number of units produced and sold. And we're making an assumption on these that they sell all that they produce, that they don't have inventory left over. So for what levels of production will a profit result? So it would be no profit if these two were equal, and it would be a profit where the revenue was greater than the cost. So if the money coming in is more than the money going out, that would be where you would make a profit. And I wouldn't have an equal sign under here because the equal sign would be, it would make no money. There'd be no loss and there'd be no gain. So I would not include the equal sign on that. So the next thing I'm going to do is I'm going to put the R there and the revenue and the cost there. So I'm going to rewrite this. 400x is greater than, and we're not going to solve these algebraically. I know that you might want to, but we're not solving these algebraically. So I'm looking at this graph here, that tells me that I'm looking for you to use your graphing calculator. So I'm going to say this is my y1. Where is my y1 greater than my y2? So I'm going to go over to my calculator and I'm going to put this on my calculator, and it would make sense that the number of units produced and sold would not be negative. So I would probably change this graph to look more like this. And when you put this in, you're going to get one of yours looking like this, and one of them looking like that. And so let's go ahead and put those in. X is the units, and the Y would be the revenue or cost. So as you drop those in there. So I'm going to go to my graphing calculator and go into my Y equals. I'm just going to clear this stuff out. And my first one is going to be 400x. And my second one is going to be 200x plus 16,000. And so now I need to think about my window. So the X represented the units. So I'm just going to go from 0 to 100. And my Y represents, I'm going to start at 0 on that, but my Y represents the cost of revenue. And if I looked at my 1Y, my y-intercept is 16,000. So it's going to be in the thousands. So I'm just going to go big. I'm going to go 40,000. Sometimes it's better to go bigger than smaller because your little blinky is going to do all the work. It's not like you have to see everything. Okay, so there is my y1, that's 400x, and there is my y2, and notice there's an intersection there. So I'm going to calculate the intersection. I'm going to let my smart bug do all the work, and I'm going to get 80 and 32,000. So I'm going to go back to here. So this was my y1, this was my y2, and this is 80. This is the work that you're showing. And my x, I ended up with 0, 100. That worked. And my y, 0, 40,000. Okay, now I need to look at my shading on here. So where is the R, which is right here, where is this line more than this line? And I know that we shaded like a whole area last time, but we're going to actually just shade where is y1 above y2. And it's going to include this. I'm just going to give that a different color. Include this, and I'm just going to shade this line. See how I shaded that? I just shaded from here up, and I actually should not have done that as a closed circle. That actually should be an open circle, because that's where they intersected. So my answer is going to be, I'm really trying to find, so this can be a little confusing, but I know I have the full ordered pair here, but I got to go back and look at what they're asking me. For what levels of production will the profit result? So I want to know what is my X that would make a profit. So my X would be greater than this 80,000. Notice it's going this way, so it's going to the right. So X is greater than 80, which means on my line, I'm not going to write X is greater than 80 because this is a word problem, so I'm expecting some words on your line. I would say more than 80 units. That's what I'm going to put on as my answer. So greater than 80 units, more than 80 units. So it would be 81 units and on. And then this is my final answer. This is my work. I have everything on here that I'm asking for. Okay, let's take a look at this one. This is more of just a calculator one that I wanted to go over with you. So where is, on this one, I'm going to make this y1. Where is y1 greater than or equal to y2? And when we put fractions in the calculator, I know I've said this a lot, make sure that if you're adding or subtracting on the top or the bottom that you put parentheses around it. So if I go to my y equal and clear those out, I'm going to put a parenthesis 5x plus 2 divided by 5. And my second one is going to be 4x minus 7 divided by 8. And these are pretty small numbers, so I'm just going to do my zoom 6 and see how that works for my window. I'm going to watch those graph, and yes, my intersection is on my graph, so I'm going to be able to find that intersection, calculate the intersection. I'm going to just push enter through these. So negative 2.55 and negative 2.15. And so let me get these on my graph on my sheet. So here is my y1. And you got to really keep track when we're in inequalities which is which. And here's my y2. And I want to know where is y1 greater than or equal to y2. So that is going to be a closed circle. Where is my y1 above my y2? And that's going to be all of this right here. So that's how you're going to show that. And this point you're going to show negative 2.55, negative 2.15. So x, when x is greater than or equal to, look at the green, this is my x. We're solving for x only. So when my x is greater than negative 2.55, another way you could write that is negative 2.55 to infinity. Double inequalities. So a student has taken 4 tests and has earned these grades, and we've done something like this before, but we're going to do this graphically. If all 5 tests count the same, what grade must be earned on the final test so that the course is an average of a B? So thinking about that, the least I can get is an 80%, and the most I can get is actually this is not going to include 90%, but it has to be less than 90%. Notice I'm putting the percents just as whole numbers. So my score, whatever that is, it's going to go right here, has to be between 80%, including 80, and up to 90%, but not including 90, because 90 would make it an A minus. So I'm going to have 90 plus 88 plus 93 plus 85 plus x, I don't know that last one, divided by 5. So I'm not going to do any algebra on this. And so I'm going to use this double inequality. So this is going to be my y1. This is going to be my y2. This is going to be my y3. Notice y1 and y3 are just horizontal lines, right? So this here could be my y3. I know you'll put this on your calculator though. This here will be my y1, and then my y2 is going to be right here. So I just want you to see what this looks like, and there's no equal sign on that. So really the area that I'm looking at is not including this 90%, but including, so where is y2 in between, not including that, it would be this part right here. So I would need to find these points of intersection so that I'm able to put in my numbers. So I need this here and this here. The x, the value of this last score, has to be between 2 numbers. All right, so let's go to our graphing calculator. Let's go into the y equals, clear that out. First one I'm going to put in is 80. And then I'm going to put parentheses. Be careful you put parentheses 90, 88, 93, 85, and x divided by 5. And then 90. Now I'm going to think about my window here. It's not going to be below 0. And I could go to 100 on both these. Again, it's not going to be below 0, right? And the scores aren't going to be above 100. So let's just see what this looks like. And sometimes these will be really small in between here. Let's see how the third one populates. There we go. And if you wanted to make this wider, you could make your minimum on your y bigger. So maybe your minimum isn't 0, maybe it's 50. And that will lengthen between here. But we can see it pretty good here. If you can't, again, do that. I'm going to just do that so you can see it. So instead of using 0, I'm going to go to 50, and let's see what that looks like. And then I need to find those intersections. So finding these intersections will be a little bit different. That makes it a little better. I could even have gotten more. So if I want to calculate the intersection, this bug is smart, but it's not that smart. So I want to find this intersection. The bug is closest to this intersection, not this intersection. I'm going to watch its hopping. So it's on the blue line right now. I'm going to push enter. It hopped to the red line. If it hopped to the black line, we'd have a problem. So it hopped to the red line, so it's going to give me where the blue and the red intersect. And that ends up to be 4480. And then I'm going to do this again. I'm going to calculate the intersection, but this time I have to get it moved up. Oops, I think I made a mistake here. I need to move this bug up to the black line and over by the red line. So it will hop only to the red line, not the blue line. So it's on the black, hop to the blue, so that's probably not going to work. And you'll get this error, no sign change. So I got to do it again. got to calculate the intersection. So I'm trying to show you where it, oops. Calculate the intersection. So I'm going to hop it up, and this time I'm going to go really way over here. So keep it going. I'm going to go beyond that actually. So let's just try that. Enter. Still hop to the blue line, so I need to do that again. Put it up. And this time I'm going to try it on the red line. Sometimes that bug gives you a little problem, so this time I'm going to go up. Now I'm on the red line. And then I'm going to push enter, it hop just to the black line. So this is trouble that you could have, so I'm glad it actually worked that way for me. It ends up to be 94.90. So that intersection. So see how I had the trouble with that? You got to really be careful if you have two intersections, which we will get to a lot as we go here. So this one here ended up to be, I'll have to look at what those were. 94.90. And this one down here was 44.80. So then if I look here, what I'm going to put in here, I'm only looking at the X, right? Because that's the score. So this person can get 44, and they can get as high as 94 to stay in the B range. Oops. So then what am I going to put on my line? I'm going to put at least 44%. And I need to take that line off there. And less than 94%. In word problems, your answers should have words in them, not just you're interpreting what this means here. Here's one more double inequality. So the mean, the expected time y served in a prison for a serious crime can be approximated by a function of the mean sentence length x, with y equaling that equation where x and y are measured in months. So if I look at this one, I have, I'm trying to figure out what my x and my y are here. Pen is acting up again. So I highlighted some things here for you. So as I said earlier, the y is typically in the front of the paragraph. So if you look at this, the mean expected time y, which is the y served in prison, so that goes there, for a serious crime can be approximated by a function of the mean sentence length x. So they are sentenced to a certain sentence, but this formula shows that you don't actually serve the same amount of time that you're sentenced to. So this is the regression equation that they already found for us to help us. So get to the other. So the next thing that you're going to do is make your double inequality here. So they want to know in how many months should a judge sentence. So they want to know the sentencing, the X, a convicted criminal, so that the criminal will serve between 37 and 78 months. So between 37 and 78, and we're in months. And so I'm going to put this equation right here. This part of it is going to go right here, because that's going to be the x that I'm trying to find here. So 0.55x minus 2.886. And again, we're not going to solve this algebraically. My y1, y2, and my y3. And we're going to drop these into our calculator. And I'm going to let you do that. I'm just going to move this a little bit. So when you do drop that into your calculator, you're going to get your 78, which is your y3. And again, if there's not enough space, don't start at 0 with the y's. And this is your y1. And then this is your y2. So what you're looking for then is you're looking where the length would be between your y3 and your y1, including them. So it's going to be all of this you got to make sure you have the shading on your graph when you're dealing with inequalities to get full credit on these. So you're going to calculate the intersection just like the last one, and you should get 147.07, and the y is 78. And then the x is 72.5237. And if you need to go back and watch that other problem to make sure you know how to do that, that's what you should be doing. So what is my answer? My answer is between 72 and a half months, right, and 147. So I'm going to just say 73. It's closer to 73. 73 to 147 months would be the expected sentence length to get the 37 to 78 served time. So you would have this, the judge would have to really sentence a much longer because they know they're going to be in there for much less time. So you have to be careful when you're sentencing for that reason. And here is the homework.